Hello, it's Duncan. Last week we learned how we can use functions to achieve polymorphism instead of classes and overridden methods. Today won't make much sense unless you've seen that episode, so if you haven't, click up there somewhere and come back when you're done. I'll wait. Okay then? Now, let's find out whether we can eliminate classes altogether, but still have a loosely coupled and extensible codebase. Just to warn you, I think that the last half of this video goes too far, but as they say, if you're not living on the edge, you're taking up too much room. Fan-dabby-dozy. In our last episode, we successfully white-labelled the Gilded Rose software. And we did that by extracting a magical goods store class here that could be used by either Gilded Rose, which is us, or Polished Daffodil, a different magical goods store. Originally we had Gilded Rose and Polished Daffodil subclasses of magical goods store, but we discovered that we could express the differences between magical goods stores as an update function. Here it is. And instead of creating subtypes, we could instantiate the magical goods store with a function that says how we update items in this particular magical world. We don't normally call this constructor though. We call this one here, which in turn takes this type for. Now type for is a function that takes an item and returns a function that takes an item and returns unit, which is this update. Why did we do that? Well, if you watch the episode, I think it makes sense. But the fundamental idea is that this is a lookup of item to something that knows how to update an item. And the thing that we're saying knows how to update an item is this item type here. What's item type? Well, at the moment it's a class and it implements this item to unit. And this class's job is to specify how to combine two things, aging and degradation, into updating an item, where different subtypes can override the aging and degradation. So if we look for a subtype, we'll find that we've got things like brie, and brie overrides item type, keeps the default aging, but changes the degradation. And the same is true for sulfurous and passes and other things. So a particular magical goods store is defined as a way of looking up an item type given an item. That's this map here in the case of Gilded Rose, and the definition of the item types. And you'll see the same thing here in Polished Daffodil, but in Polished Daffodil the lookup is a when and not a map. So we use a reference that function there when we're building a magical goods store, and in the case of Gilded Rose, we use a lambda, here it is, that looks up in the map. So this item type, I'll move it over here, allows us to compose aging and degradation into how we update an item, but we have to subclass item type in order to do it. Now, there's nothing wrong with writing a subclass, but it is true that we need to do it at compile time. Maybe though we'd like to generate new item types to compose different ways of aging and degrading at runtime in some sort of way. How would we do that? Well, we've already seen a way of doing that when we converted the subtypes of magical goods stores. We did it by making the variation in the behaviour a property of a class that we don't subclass, rather than methods that we do. So let's see if we can pull the same trick with item type. Here it is again. And instead of migrating all the customers using this item type, I'm going to create a different item type, and I'm going to call this one class FP item type for functional programming. Now we want that to be substitutable for our normal item type, and our normal item type at the moment is actually this item to unit type here. So I'm going to take that and I'm going to say that our FP item type should be one of those as well. And in fact, I'm just going to take the whole body of item type as well to make it compile, like that. And now we're going to play the same trick as we did last time to make these methods into properties. They're not going to need to be protected or open anymore. But we're going to say we've got this val called aging, which is a fun that returns 1. And I need to get rid of those brackets. And now it's a value with a function type. This compiles here. And we'll do the same thing here. We'll say we've got this val called degradation for, and that's a function that takes an item and is defined with this body. And that again makes this compile. This is currently unused, but I'll just run the tests to check that all is well. And now what we're going to do is we're going to move these properties to the constructor. Don't think that it automatically works. Oh, move to constructor. Maybe it does. It does, splendid. And we'll do the same thing with this one. Move to constructor. Now there's a simplification we can make here. Actually, we could have made it with item type as well, which is this aging, either as a method or a function, takes nothing and just returns a constant. So I think actually we could say that that is just an int. So it's not a function, it's just an int that is 1. And then instead of calling it as a function, we'll just reference the property. How will we use that? Well, let's go over to Gilded Rose and see what to do with other. At the moment, that's item type. What happens if we made it FP item type? And now it can't be an object, but we can make it a val. So we say this is a val other equals just create me an SP item type, where this at the moment has the same default behavior as our open class item type here had. We get a compile problem here, and that's because this type lookup says that its type is string to item type, but now we're mixing in an FP item type. I wonder if we can fix that. I'm expecting IntelliJ to do that all by itself, but let's see what Fix with AI does. It makes a little purple animation, that's what it does, and undoes our change. Thanks very much. Let's undo that. And we'll fix it by hand by noting that the common supertype of item type and FP item type is item to unit. So we can put that in here. Item to unit. And now I think everything will compile and pass the tests. Good. Now then, I'm not sure the default values in here are helping much. They're nice when we're subclassing item type, because otherwise we'd have to define a function in Bree, for example. But just passing 1 in for that would seem to do, and that would get me get rid of that. And I think I'm going to do the same with degradation. So let's first of all convert this to a lambda. Now we will take the lambda, cut it out of there as the default, and if we paste it outside the brackets here, that should still compile and pass. Good. And I think what I'm going to do is I'm going to drop that down there, and I can probably get rid of that type. Okay then, let's go on to sulfurous. We also need to make that a private val, which is going to be an FP item type. And its aging is going to be 0. We can see that there, so we'll do that. And its degradation for is going to be 0 as well. So that will just be a lambda that returns 0. And we need to put in the equal sign rather than subclass. There's a little bit of a problem now that the type lookup can't see sulfurous because it hasn't been defined yet. We're not given the choice of just moving it up, so let's do that by hand. And in fact, we'll do it for all of these, shall we? Because we can see which way the wind is blowing. So I'm going to cut those out of there, and we're going to put them up above there. Does that pass? Splendid. Now Bree. We'll have a val Bree equals an FP item type. We know that the aging is going to be the default, and the degradation we can implement by deleting that and making that into an arrow. Are we good? We are. Now, so far we've been building a new FP item type from scratch, but it might be that we think of Bree as whatever other is, but just with a different degradation. In that case, I think we might say that other is not other, but say standard. And what we might want to say is that Bree is like standard, it just degrades differently. And that's pretty much what we had when we subclassed item type instead of item. And we can achieve it here by making this a data class. And if we do that, then we can say that Bree is standard, copy, where degradation for is this lambda. Is that true? Brilliant. And then we can play the same game with passes. We'll make that a private val of standard.copy, degradation for equals our lambda. Are we good? We are good. And now if we added other ways of updating items to standard, they would be inherited by Bree and passes. Finally then, conjured cake. This is special because it uses super degradation for. So we're saying it degrades by twice whatever the super type does, and the super type is item type. So let's see where we get. We'll make this val conjured cake equals standard, copy, where degradation for equals, and now what is super degradation for? Well, it is standard degradation for it. Is that true? Oh, good. So that's quite clever. You can see that in the FP item type world, the thing that we're copying from and overriding bits of is like our superclass. And so we're copying from standard here, and so standard degradation for is the same as super degradation for. In fact, that duplication, standard here and standard here, gives us an opportunity. I think if we were to make a method out of this and call it conjured, oh, that really didn't do what I wanted it to. Let's undo, and I'm going to put a run around this to give us something to make a method out of. I'm going to say surround with run. Now I think if I take this thing and make a method, that will do. We'll leave the name alone. And now I'm going to make this a parameter. And there are two of them, so we're going to call that base. And now if I make that the receiver, then this function conjures its receiver. So I think we could call this conjured. And now we can get rid of the run by inlining it and see whether it works. And it does. Good. Now the fact that conjured cake is standard conjured might make us wonder whether we can conjure other things. And indeed we can. And I'm going to prove it, in fact, by removing the conjured cake altogether and conjuring standard. So I'm first of all going to return this lookup to map of string to now FP item type, because that's true. And I'm going to remove the conjured manna cake from here. And likewise there. Now if we go up here, once we've made the lookup, let's assign that to, say, base. We can say if it.name starts with conjured, then I want base conjured, else base. Jiggle that about a bit. And as the tests have conjured manna cake in them, if it passes, we are good. I think that's worth a check-in. Let's see what AI Assistant makes of that. Refactor item type logic using functional programming approach. Replace inheritance-based item type hierarchy with a data-driven FP item type model using function properties. Well, I've got to say, I think it gets it. Brilliant. Commit that. So that we can see everything, I think I'm going to take this and move it over here for now at least. That will break something here. It will just import. Okay. So now then we have two different item types. We have an object-oriented one with method overloading. That's still being used by Polished Daffodil over here. And we have an FP one here with a function property. That's used by Gilded Rose. But the magical goods store here is only using item to unit type, which both of our item types implement, so it's happy to use either. Could we go further with eliminating classes? Well, we can if we're prepared to give up this copying of standard here. Let's have a play with that. If we didn't copy standard, then Brie would be FP item type 1 with this degradation for. Passes would be the same. And we also need to get rid of that irritating bracket. I'll just run the test to check we're on the right lines. And we are. And now our challenge is to implement conjured without copying an FP item type. So what to do? I'm going to give this a block body. And in fact, I'm going to say that I would like conjured to apply to any item to unit function. And it is also going to return item to unit and not FP item type. Right, how can we do that? Well, we need to return a function that takes an item. And what we can do, as the AI is suggesting here, is we can ask the initial function, this one here, to update the item. So we say this, and I'll put the invoke in so you can see it, item. Now that won't be conjuring, it will just be doing whatever the initial function is doing, and if we run it, it will fail to conjure our manna cake. Good. Okay, if we've only got item to unit, we can't ask it how much it is about to change the quality, but we can find out how much it did change the quality. So we can say val initial quality is the item's quality, and then we can ask the base function to do the update, and then we can say val quality change, our initial quality minus the item's new quality. And now we know what that quality change was, we can apply it again. So I think we'll take this code here, which enforces our limits, and I'll copy it into here. And so our new item quality is the item quality minus the quality change. Are we right? Ooh. Now you may be thinking this is a little dubious, and I think I agree. And that dubiousness is one of the reasons that functional programmers almost certainly wouldn't update the item. They would have returned a copy of the item. But in Gilded Rose, we are where we are because of the goblin in the corner. Ignoring that little feeling in the back of our head, we can convert this to expression body. If I'm returning a function type, I often will leave it as an anonymous function like that. We're still good. And now we've got rid of all the copies. FB item type doesn't need to be a data class. And if it doesn't need to be a data class, then we really don't need these to actually be properties. If they're not properties though, how do we use them in this invoke? Well, let's make the refactoring. What we're going to say is we're going to make this to a function that takes aging and degradation for. And in order to compile, this function has to return something that takes an item and returns unit. And in fact, inside these braces, we had that function. So we can take that away and return a reference to that function. I was about to check that would run, but I see it's not compiling here. That's because FB item type is now not actually a type. It's just a function. No worries though, because we can still substitute item to unit to get that to compile. It passes the tests. And now this aging and degradation are captured by the compiler when it defines this function. There'll almost certainly actually be a class involved here somewhere, or maybe some Java invoke dynamic stuff. We can inline that. But maybe, in fact, I really want an anonymous function that I can convert to an expression body like that. Now then, this constructor, because it is constructing something with this type here, we can rename to be ItemType to assuage the compiler's warnings. And now over here, you can see that sulfurous is an item type with an aging of 0 and no degradation. Brie is an item type aging of 1, and so on and so on. Fan-dabby-dozy. If I now say that the only uses of this item type are in polished daffodil, I can move this to the package of polished daffodil. We want to leave the functional solution here, move the class over into polished daffodil, add that, and now our Gilded Rose implementation is only in terms of functions. Except Magical Goods Store is still a class, but it's another class with only one public operation, update quality. So let's take that and say that it implements a function type, which is the function signature update quality, which is something that takes nothing and returns unit. It must work entirely by its side effects, in this case, updating the items in the list of items. Let's implement that with an invoke. And now let's copy the update quality into invoke. And we'll make update quality, invoke. That should be the same, passing the tests. And now if we inline update quality, let's see where it's used first. It's just used there. So if we inline that, then here now we are just saying app invoke, or we could take that out altogether. Good. Back to Magical Goods Store. Make this a function. These won't be vals anymore. They'll just be plain parameters. And the body of the function is going to return a reference to that invoke fun. Are we good? We're good. Now we can just say return fun, removing the name. Get rid of that. Make this an expression body. Deal good. And finally, we might like to rename this to be Magical Goods Store with a lowercase m. Things go a little bit horribly wrong there. See whether we can get away with that. Does it build? No, because magicalgoodstore.kt doesn't know what it's calling. I guess that it doesn't know that it's not calling itself. And I think the real issue here is that type for and update are both functions that take an item. We can disambiguate by saying this is update equals that lambda. But now we have an issue that these are the same thing apparently. We might finesse that by giving one of these a JVM name, but that's hard because the build has failed here, but IntelliJ isn't giving us a warning here. I think discretion is the better part of valor. I'm just going to rename this one to be Magical Goods Store with, make that one Magical Goods Store with. Now we can remove the name and remove the lambda. Are we good? Oh, we are. So there we have it, Gilded Rose with polymorphism using functions, but no classes. Well, technically there's one class here, but I think I'm going to claim that that is really only data, as it carries no significant behavior. For me, composing behavior with functions rather than the data class we had in the last commit is probably going too far. Going too far does allow us to see the relationship between functions and classes, and that's a good thing. But given that we have data classes in Kotlin, I don't think this is with the grain of the language, and so I am going to roll it all back. Well, I hope you enjoyed that. If you want more of this sort of thing, if you're watching this video straight after it comes out, it may not be too late to sign up to Nat and I's workshop at CraftConf in Budapest. If it is too late, then maybe you should have subscribed to the channel and hit the notification bell. So why don't you do that now? Go on, just do that now. Thanks for watching.